All right, guys, so we are on page 11 of our notes. We're going to learn a couple more terms today, do a couple more practice problems. So after watching the video, like usual, you're going to answer those couple of questions on the Google form. And like I've been telling you, I am not grading you on whether you get them right or wrong. I need to see what people are having trouble with, what misconceptions they have. All right, if you're getting every single question wrong every single time and you show up to class without your notes done, then obviously we need to have a talk, and I'm not going to give you full credit for that stuff. But I want to see your honest attempt at this. So that's first thing. Second thing, I want to give a shout out to the students who are all remote, who have been taking advantage of my activity period Zoom meetings and my office hours on Wednesdays. All right. A lot of this responsibility is going to be on you this year. We don't have that in-class time to talk about things that are giving you trouble. You can't just say, Mr. Klemp, I had a really hard time on number 4 on the segments classwork. Okay, so those classwork assignments that you're doing at home on your own, you'll get some feedback. Like it'll tell you whether you got them right or wrong. But if you don't understand your mistakes, you have to come and get help from me. Okay? And I know it's kind of unfortunate because you guys don't have that extra class time. It's a little more work on your end, specifically the remote only students. But this is a really important unit. We're going to build on this stuff throughout the rest of the year. So if you're not understanding something, if you're totally lost, don't just say, forget it. I'll figure it out next unit. You have to put a little bit of the responsibility on your shoulders. Come in to ask me questions during those Zoom hours that I have available, and we'll figure out what we need to work on that way. All right, the few students who have done that, I think they would really agree that it helped them a lot. It just kind of eases their mind. It's frustrating not understanding something. So come in, get some help from me if you need it. Anyway, for our notes for today, again, pause, rewind, rewatch, whatever you need. We're going to look at some pairs of angles and their relationships. All right, so we learned about naming angles. We learned about angle measures last time. Today, we're going to learn a couple of little things. So two angles are complementary or complements of one another if their measures add up to 90 degrees. All right, that's something you've learned in earlier math classes, I think. So questions you might see, so like for number 1, I'm giving you this picture. This symbol right here means 90-degree angle. It means that angle is a right angle. All right, so I'm giving you a little of information here. If you want to try this one on your own, you can play around with that. But like for the first one, the measure of angle PMQ. So PMQ, we talked how important it is last class to know how to name angles. PMQ is right there. I know this whole angle is 90. So I'm looking for the measure of angle NMP. So I'm looking for this right here for question A. So using our addition postulate for angles, we know that the whole is equal to the sum of its parts. So I could say, 42 plus what equals 90? 42 plus what equals 90? Probably a little more straightforward. We can determine a little quicker. I can say, all right, I have 90 degrees. I've used up 42. I can find the measure of this missing angle by just subtracting. All right, so that's how I would get 48 degrees for this missing angle here. Okay? So complementary means they add to 90. This question here that deals with ratios, I want to save this for our bell ringer for the next time you're in class. All right, it's a really kind of a neat thing to look at all the different ways people have to use these ratio questions. So I want to talk about that as a group. So hold off on that one. But big idea for this first page, complementary angles add to 90 degrees. I'm going to move on. So if you need to pause and rewind, do it now. Okay. Supplementary angles. Supplements are angles that add up to 180 degrees. So a little trick that my geometry teacher taught me back in the day. The way to remember the difference between these, supplementary, if you draw a little line through your S like this, it looks like the number 8. So that 8 from the supplementary helped me remember the 180 degrees there. So that's how I kept complementary and supplementary different. So keep that in mind. Okay, so we also learned last time that straight line angles equal 180 degrees. So it kind of makes sense from that. If I take a straight line and draw one ray off of that, or 2 or 3 or 4 or any number of rays, all those angles together, all those angles together have to add up to 180. So in this question, if I were to be solving this, I would say angle A plus angle B equals 180 degrees. All right, so we talked about that in class with the people who were in person. Our job for a lot of this year is to come up with true math sentences and true math equations. So in this case, I know those two angles added together must equal 180. Okay, we have another ratio question there. So like for number 3, for example, I don't think I'm going to solve this all the way out. You guys can try this on your own. But if I were to need to set up an equation here, I look at this straight line. So right away, I know that this is a 180-degree angle. I have 2 measurements coming off of this straight line. So I will know, given those 2 measurements, if I were to add them together, the only way that this works, the only relationship that I know is that those 2 angles together, so you can see I have my first angle, 2x minus 12. I have my second angle, 3x plus 22. Adding those together, the whole is equal to the sum of its parts. Those 2 angles together have to add up to 180. Okay, so I'll do a little solving. I'll get x by itself. And then notice in geometry this year, I might get x equals. I might find my solution. But then it's also asking me to figure out what the measure of each of those individual angles are. Okay, so maybe we'll do a little bit of practice. Maybe I'll pause my video here, and you can do the same thing. So I'd like you to pause right now and then try this question out just to test our algebra skills, and then we'll move on. So I'm going to pause mine now, and then we will move on together. Okay, so there's my work. You can see I combined like terms. I got the x's all on one side. I divided by 5. If these types of things are giving you trouble, this is definitely something to come into a Zoom and we should work on together, just this equation solving, because we are going to need these skills throughout the year. So once I found what x was, I was very careful to answer the actual question, which was asking for the measure of each individual angle. So I plugged in 34 into my equations, and I got 56 for the first angle and 124 for the second angle. And that checks, right? Because those 2 added together add up to 180. Okay, another very important definition for this year. 2 adjacent angles that lie in a straight line, so adjacent means right next to each other. 2 adjacent angles that lie in a straight line are also called a linear pair. So looking at this example above, these 2 angles, you'll also hear the word linear pair describing these 2 angles, which, it makes sense, right? Linear means line, pair means 2. So 2 angles on a straight line. Okay, I know I'm going quick. Hopefully you're keeping up with me. Pause, rewind, whatever you got to do. Last page. We will come back to this in class. We're going to do actually a proof with this as a group. Well, maybe not as a group, but in small groups. We're going to prove this next rule is true. And this is where you guys get to argue with each other. You get to come up with some theories, you get to come up with some arguments, and you get to try to disprove someone else's line of thinking. So the people who are remote, I'll have you probably try this on your own at home, and we can talk about this next time we see each other. But this is a kind of a fun thing. Using that linear pair that I just talked about, we're going to prove this next rule. All right? So the angles opposite each other when 2 lines cross are called vertical angles. And this is a rule that's going to come up a lot this year. So I guess not a rule, but a relationship. Vertical angles. Vertical angles are always congruent. And I know I keep using that word. I apologize. We haven't really officially defined that yet. But congruent means that they're the same measure. And that symbol for congruent is the equal sign with the little tilde above it. All right. So it really means the same thing as the same. They're equal. But congruent means they have the same measure. All right. So in this picture here, I have 2 intersecting lines. So a pair of vertical angles, for example, would be those 2 right there. So if I use my angle naming very carefully, notice I can't just call it angle A, because angle A could be this angle, could be this angle, could be this angle, could be this angle. Angle A could be any of those. So I have to name it very specifically. So I can say angle DAC, which is right here, is congruent to angle BAC. right? The middle letter is the one that matters. B, A, E. So that would be an example of two angles that are congruent because they are vertical angles. So really what your job is going to be is to determine what the relationship is. So if I give you a question and I say, what's the relationship between those two angles? You'll have to know they're a linear pair and that they add to 180. So your relationship would be this plus this equals 180. If I give you information about these two angles, you'll have to identify that they're vertical angles, and your relationship would be that they were equal to each other. So it's all about coming up with true math sentences, right? Putting the equal sign in the right spot and solving for what we're looking for. All right. So like, for example, here's what a pretty straightforward vertical angle question would look like. There's two intersecting lines. The angles are not adjacent to each other, they're across from each other. So this relationship would be that these two angles are equal. I would set them up, I would say 110 equals is the same as, right, that's what an equal sign means, that they're the same, is the same as 2x plus 40. And then I would solve from there. So you can't let yourself go onto autopilot. You have to think carefully about what you're doing. In these angle questions, it's not always going to be as simple as just equaling to 180. It's not always going to be as simple as just equaling to 90. It's not going to be as simple as just equaling them out to each other. You have to think very carefully about what the relationship is that you know. Okay, there's our notes. Do the Google form, please. Check in with me if you have big questions. There's a few pages of practice problems. Maybe we'll look at those in class next time. But that is your assignment. I hope you guys are doing well, and I will talk to you soon. All right, bye.